Hello everyone, welcome back to the course Python Fundamentals Building Blocks for Aspiring Developers. We will continue with the third module, that is control flow. We are at the day 10 of our agenda where we will look into loops. So let's begin with loops. So loops are basically a kind of control flow, you can say, which allow us to execute a piece of code repeatedly. It is based on a condition, like if a condition exists, if a condition is true, then it keeps on executing the same piece of code again and again. There are basically two types of loops in Python, the for loop and while loop. We will have a look at the differences for them. But first, if you look at the image over here, you can kind of see the visualization of how loops work. So for a moment, if you ignore the for loop and just look at the while loop, just for conceptualization. So you see that we start the code from init, then let's say we defined a loop. So there's the condition. If x is less than 5, the loop keeps on executing the code within the loop. So it performs some operation I1, performs some other operation I2. That is the end of the code in the code block. It goes back, it checks the condition. If it is still true, it again performs the operation I1 and I2, goes back, checks the condition. Until and unless the condition is true, it will keep on doing this cycle. Once the condition becomes false, then it will exit that piece of code and move on with the rest of the code. So the for loop, so it repeatedly executes the code according to the number of iterations defined. So it is slightly different from this visualization. In this one, it checks the condition at each iteration. While for the for loop, what we do is that we kind of define the condition in the start, that how many iterations this loop needs to do. So this can help us to iterate over sequences like lists, tuples, or strings, which are basically a collection of items, and the block of code is executed for each iteration. If you look at this example, we say for I in range 5. So range 5 tells us that okay, this loop should have 5 iterations. Like the code within this loop should run 5 times. So we have the code that is just printing the value of I. So this print will be executed 5 times. Now the I variable here is used to keep track of the iterations. Like it starts from 0 and it goes for 5, 0, 1, 2, 3, 4. So it goes from 0 to 4, that makes 5 iterations. So in the first iteration, the value of I is 0, so it will print 0. In the next iteration, we are moved on to the next iteration, to the second iteration. Now the value of I for the second iteration is 1, so it will print 1. And for the third iteration, it will print 2. And once it has reached 5 iterations, it will exit out of this. And now if we look at the while loop, it is slightly different. So it continues until the condition is true. It checks the condition at each iteration, and we need to write some code to stop it from running indefinitely. So for this one, if you see, I have defined a variable x is 0 and I have a condition while x is less than 5. So x is less than 5, this is true. If this is true, the code in the loop will be executed. So it will print the value of x. Now for a moment, let's say I do not have this x plus equals to 1. I just have this print x. So what it will do is that it will check at each iteration, okay, x is less than 5, print x. Go back, check if x is less than 5. Yes, it is, print. It will keep on doing this, But you see, it will then run indefinitely. It will not stop. It will run forever. That is not what we want. We want to stop it after we have achieved our purpose. So let's say I only want to run it up till 5. So what I do is that after each iteration, I add 1 to the value of x. So after the first iteration, x plus equals to 1 is simply x is equals to x plus 1. So I'm just adding 1 to the previous value of x. So previously it was 0, I added 1, now x is equals to 1. It goes back, says, okay, x is a value of 1, it is less than 5, condition is true. Go on to the next iteration, value of x is updated, it has now become 2. Go back, check the condition, it is true, run the code, go on, go on, go on. Now when x becomes 5, it will check, okay, x is less than 5. No, this is not true. It will then exit the loop and go on with the rest of the code. So for this, let's try and visualize this of how it will happen on a whiteboard. So we have this whiteboard. So let's say we have a value of x. So let's say x equals 0, and let's put it over here. Let's say, let's write the Python code over here. So let's say if x is less than 5, do this, and x, and x is equals to x plus 1. So this is what x plus equals to 1. This and this mean the same thing. So I can either write this or I can write this. But for this one, just for simplicity, I will write this. So let's keep it like this. So let's say we have this code. So now let's keep a track of the iterations over here. So let's say, okay. So this is the first iteration. So x has a value of 0. It says x is less than 5. Yes, it is. The value is true. It will print the value of x. What is the value of x? It is 0. It will say, okay, print 0. And now it says add 1 to the value of x. Now what it becomes? It becomes x. In fact, it should be x is equals to 0 plus 1, and now it is equal to 1. So now this is one iteration complete over here. Now this here goes back from here to here. It checks, okay, now x has a value of 1. Is it less than 5? Yes, it is. It will move on to the next iteration. So it says, is it less than 5? Yes, it is less than 5. Print the value of x. Now the value of x has been updated. It has become 1. So it will print 1. Now we again do this. Now x becomes 2. This iteration is now completed. Now it goes back again. Now it is 3. So it says it is 2, true. Now the value of x is 2. It prints 2, and the output will be 2. And now the x value that updated will be this 3. Third iteration is completed. Similarly, we will have the fourth iteration complete, and let's say we have the fifth iteration complete. So it says this is true, and it will print 4, and the value of x is now equals to 5. So once we have this iteration 1, 2, 3, 4, 5, so it goes back and checks. It says, okay, this condition is now false. So I do not need to execute this code. So this all will not be executed, and it will move out of the loop and carry on with the rest of the code that we have. So this is basically how loops work. So I can have as many number of lines of code I want in this if statement. Now let's try and visualize for the other one. So let's just clear it. Let's just clear the board for now and do this. Just clear it. In fact, so now let's say we want to define another one. So let's create a text box. So let's say I have x is equals to 0, but we don't really need it. Just putting it here for I in range 5 and it says print the value of I. So this is now our code. So now in this one, we already say like, okay, this will already have 5 iterations. So 1, 2, 3, 4, and 5. So it will have already have 5 iterations. It will already know from the beginning. We don't really need this value here because it is of no use here. It is not used here. So what it says is that, okay, for I in range 5. So in the first iteration, the value of I will begin from 0. So it says I is equals to 0. So it says, okay, print the value of I. So it will print 0. Moves on to the next iteration. It does not need to go ahead and check for condition. Why? Because we already told it that it has to run 5 times. So in the next one, the value of I will keep track of the iterations. So the first iteration is the value of I is 0. For the next one, it becomes 1. So it prints here. So it becomes 1. Now for the next iteration, it becomes 2 and it prints 2 over here, and for the next one and for the next one. So now we have reached the 5th iteration where it will print 5. Value of I is 4. So you see the 0 index here again, 0 1 2 3 4. It is not up till 5, it is up till 4 because 5 iterations have been completed. So once it reaches here, then it says 5 iterations have been completed. I do not need to check for any condition. Exit out of the loop. That's it. So that is the concept behind it. So let's go ahead, continue with our slides, with the lecture. So loops also allow some control statements. So these allow us to manipulate iterations. So for example, you do not want to complete all the iterations. So there are two types of keywords, continue keyword and the break keyword. So the continue keyword. So it is used to skip the code in the current iteration and move on to the next one. So let's say you have a condition. If that is true, you do not want to execute the code in this current iteration. You just want to move on to the next one and just skip the code for this one within the loop. So we can do that one using the continue keyword. And for the break keyword, what we do is that if we use the break keyword, it will just exit out of the loop. It will not see how many iterations are left. If the condition is true or not true, it will just exit out of the iteration at that moment. So this is how it works. So we say while x is this, if x is equals to 3, continue. So what this means, that is, if the value of x becomes 3, it will just stop here and just go back. It will not execute the code after this continue statement. So this print x will not be executed. It will go here, do this, go on to the next iteration. Now this condition is not true, so it will just print this one. So this is how we use continue keyword. We can also use the break keyword. So let's say if we are doing this code printing, so once it says x is equals to 2, x becomes 2, we break. Now it just exits the loop. It does not execute this code. It does not go back again. It just comes out of the loop. So this is how we use both of them. So let's start coding. I will go back to the same code, VS Code, remove the previous code, and let's begin. So first, let's have a look at the while loop. So for the while loop, I have to have a condition first. So I say while x is less than 5, do this. I want to say print. Let's first print hello, and again the condition to stop the loop from running forever is x is equals to x plus 1. We can also do it x plus 2, x plus 3, whatever you want, but we want to just skip one iteration. So do this, run the code. Okay, it is not running because x is not less than 5 in the start. It is 5, so this condition is false. It does not execute anything. We need to make it 0 over here. Do this. So it prints it 5 times. 1, 2, 3, 4, 5. It runs 5 times according to the concept that we just learned. We can also here print the value of x at each iteration. Save it, run the code. So you see 0, 1, 2, 3, 4. At first iteration it is 0, then it becomes 1, then becomes 2, then becomes 3, then becomes 4, then becomes 5. Now if I do this, print hello, or let's say print by, do this, everything here runs, it then it prints this one. Now if I do it like this, 5, now this while loop should not execute any code here. It should simply go over here because this is not true, this condition, anything in here will not be executed. It just moves out of this and carries on with the rest of code similar to the if else statements. So you see only printed this. Let's go ahead, do this, and you can also change the number of iterations. I say 3, save it, run it, only runs the loop for 3 iterations. This is how we use while loops. Now let's have a look at the for loop. Let's remove this code. Let's say for loop, and how we do is that for I in range, give a range of 5 here. So this this is just a variable, we can name it anything, we can name it k, we can name it like iteration, anything we want, but we use just I here because this is the convention, so it is easier for everyone to follow if you use I. So go here, print, let's first print hello, and let's print here bye, save the code, run the code. So again this will run 5 times because we have already told it to run 5 times, so it prints the hello 5 times. Similarly we can also print this I. You must remember that I is a variable, it is nothing special, it is just a variable that keeps track of the iterations, like at what iteration are we at now. So it is a variable, that is why we can also use it in any way that we want, but we do not want to update it, like we do not want to do I is equals to I plus 1 because this will just mess up the loop. So if you're using this, you do not need to update it, you can print it, you can compare it, you can use it in a if statement, if I is equals to 4, anything, but do not update it. If I do this, run the code, and we have the same output 0, 1, 2, 3, 4. For 5 iterations we have 5 values over here. So this is how we can run the for loop. Now let's have a look on how these loops can be useful. So let's say I have a question that find the prime, or let's say find the number that is divisible by 13 between the numbers 2 till 30. So I have a question that says I want to find all the numbers which are divisible by 13 and between the numbers of 2 and 30. So where I want to start at 2. So I say x is equals to 2. I have an initial value. Now for this one I want to use a while loop because I do not want to calculate how many iterations there will be. I can calculate it. I can do 30 minus 13, so that comes up to 30 minus 2, that comes up to around 28 iterations. I can write using a for loop, but I do not want to calculate it. I just want to use the while loop. So I say while x is less than what? We have the upper limit of 30. So we say while x is less than 30, do this. And in this one, we can also use a if statement. So we say if x modulus 13 equals 0, we say print x. Okay. And at the end, we say print end. So what it does is that in the while loop, it will execute this code. So we've already learned about if, so it will check if this condition is true, then do this. Now this condition, why are we using the modulus? Because if we divide something by 13 and the remainder is 0, that means that that number is divisible by 13. If it is not divisible by 13, then we will not have a remainder of 0. So this is how we can check it, similar to the even and odd numbers. Save it, run the code, and okay. So you see now it is running. I did not specify an end condition, so I need to stop the code. So to stop the code, you can simply click here and Control C. So that will stop the code. So you see it was running forever, not showing any output. So what I need to do is that I want to say x plus equals to 1. X is equals to x plus 1, same condition. Do not want to put it in the if statement. I want to put it outside of the if statement. So it is directly in the while loop, not within the if statement. Because I do not want to update the statement only if it is true. I want to update it every time the loop is running. Save it, run the code. So it says 13, 26 and end. So you see how simple was that. I can even do a bigger number. Let's say 200 for the first 200 numbers. So I have this here, 13, 26, 39, all this. You see how simple was that. So this is just a very basic example, but once we move on to different algorithms, we will kind of use these things, because algorithms are created based on these type of computations. So we will use these computations with a lot of code. When you will start coding, you will use these while loops, for loops with a lot of other code, but the basics will be the same. Now let's say I have another question. So it says for each of the numbers from 1 to 5, calculate the square of the number. So as I have like numbers from 1 to 5, or let's say from 0 to 5. So this means that 5 is included. So I have 6 numbers, 0, 1, 2, 3, 4, 5. That are 6 numbers. So for each of the number I want to compute a square. So what I can do is, one way would be that I say print 0 squared, I say print 1 squared, I say print 2 squared, and so on. I write this 6 times, but that is not efficient. This is where we use for loops. So let me get rid of this one here, and for I in range, so what range do we want to put here? Because we have 6 numbers, we say 6, because 0 to 5 is 6 numbers. If we put it 5 over here, it will stop at 4. We want it to run up till 5. So this is why we put 6 over here. And why the for loop? Why not we using the while loop? Because we already know the number of iterations. We know that we only have to go for this number of values. We do not have to calculate this number of iterations. Like for this example, if we were to do a for loop, we had to calculate the number of iterations between 2 and 30 and then use it in the for loop. For this one, we can directly do it. So this is why for this case, for loop is a better choice. So I say print I, this and square. I also want to print the value of I just to see what the value is, and in the end let's say print and save it, run the code. So now it says okay, for the value of 0 the square is 0, for the value of 1 the square is 1. Now for the value of 2 the square is 4, for the value of 3 square is 9, for the value of 4 it is 16, then 25. So this, I just put this print statement for you to visualize. I can get rid of this one, just do this, and it says, okay, for number 0 to 5, these are the squares for each of the numbers. That's it. You can increase the number. Let's say someone want to ask for the first 15 numbers. I do not want to write for 15 numbers. I just do this, I get the squares. You see, so quick and simple. Right now we're just using smaller numbers, but this can come up to a lot of numbers, maybe hundreds of iterations, maybe thousands of iterations. So that is why you see we need to write code once and iterate over the code lots of times rather than writing the same code thousands of times. So this is how we use different loops. So that was all in this lecture. I would suggest you try and find different use cases for loops, try and implement them, try and see if you run into different errors, and then go back to the lecture and solve those errors. You need to make sure that um, you learn about the loops really well, because loops and conditional statements and this control flow thing, all of these concepts are used too much in Python in algorithms, because all of the algorithms are based on these ones. So keep on practicing hard on these ones, and we will see you in the next video. Up till then, goodbye.